Okay guys, so we start with the tutorial discussion for question number 1 up to question number 9, but we focus more initially on the buck converter up front. Okay, so actually this question number 1 is similar to question 6.8 from our textbook. Okay, the buck converter has a resource mentioned here, V out, frequency and the power. So all the statement here we transfer into circuit. So we write down all the given parameters of V source 30 volt, V out 20 volt, switching frequency 40 kHz, output power 25 watt, and the inductor current is 25% of the average inductor current. So 25% minimum inductor current, so I and min is equal to 25% of IL, average inductor current. So we write inside all the circuit available information into the circuit. Okay, first of all, what we need to do is that we find out the most important parameters which is left unexplained over there on the duty cycle, and the output in terms of resistor, and then we find out the L and C here. Okay, was stated that V out equal to D times Vs, or Vs times D. So the duty cycle here is equal to V out over Vs. V out given 20 volt divided by 30 input, so we have 0.67 ampere, sorry, 0.67, and P equal to V square over R. So we need to find R, so R is equal to V square over P, which is 20 square divided by 25 watts. We get 16 ohm as our output resistor. Then our average IL here, average output current is equal to output voltage divided by the resistor value, which is 16 divided by 20 divided by 16 volt, 16 ohm, sorry. So 20 divided by 16, 20 volt divided by 16 ohm that we have calculated just now. Okay, we have the value of 1.25 ampere for average inductor current. Then we have been we know that the IL minimum is equal to V out times I over R minus 1 minus D over 2LF. So IL minimum is 25% of I average. So 25 over 100% times 1.25 equal to V out of 20 volt, 1 over 16 ohm minus 1 minus 0.67. So the output of the circuit is 0.67 over 2L F. So L here is L minimum. So we are finding out what are the minimum L and minimum inductor to produce this 25% and 25% of IL average. So divide by 40k. So the IL minimum is 0.312 actually ampere, equal to the formula that we put in all the values. So we shall get the L minimum of 0.88 micro Henry, right? So this is the value for minimum inductor value to provide minimum inductor current of 25% from the average. Is that when we have the inductor, so the minimum here is 25% of average, and the minimum here, minimum inductor current, when we use this value 88 microhenry, so it will go down to 25% of IL average. So all the values obtained, the I average, I minimum, and the inductor current inductor value for the converter. Okay, next question 2, which is actually from our textbook, is similar to question 6.9, the example of 6.9. So buck converter input voltage which varies from 50 to 60 volt. So we assume that this is our battery. When full charge has 60 volt. When the charge depleted, so it reduced to 50 volt. And our load, which is varies from 75 to 125 watts. Let's say we put in more loads, so put in more light bulbs or whatsoever, so the power increased to 125 watts. If we reduce the load, we switch off a few bulbs, so reduce to 75 watts. So both input and output are varying. And in terms of voltage, we are maintaining the voltage of 20 volt. So we put in all the parameters given here into the circuit. So we have 100 kilohertz of switching. So what we need to find is the inductor value to set the system on the CCM mode, means that it will be continuous supplying the current regardless any voltage at incoming and regardless any power at output. So we consider we need to find the duty cycle. We consider both in terms of duty cycle and the output resistor value. So at 50 volt scenario, 50 volt input means that we consider the input may be reduced to minimum input voltage. So the duty cycle would be 20 divided by 50, V out divided by source Vs. So 0.4% or 0.4 ratio. At 60 volt, the duty cycle might be 20 divided by 60. So 0.33 ratio. So in terms of power or the output resistance, when the power at 75 watt and at lower power, so how much the resistor value? So V squared over R. So we have 5.33 ohm at P of 75 watts. At P equal to 125 watts. So with the output voltage of 20 volts, so 20 square divided by 125, so we get 3.2 ohm. So these two values are going to be used at our output resistor, and these two values of input duty cycle will be used at our incoming due to the variance of input voltage. Here are the variance of the output resistor due to the variable output power. Okay, then we need to find out what is the L minimum. So L minimum to maintain the continuous current mode for this circuit. So we found that we have four scenarios here, two variable of resistor and two variable or variant of duty cycle. So we have to consider all the variants. So at duty cycle of 0.4 and R of 5.33 ohm. So using this formula, so L minimum we found out to be 1 minus 0.4 of duty cycle times 5.33 divided by 2 times frequency 100 kilohertz. So the value of minimum inductance for that scenario is 16 microhenry. Meanwhile, at 0.4 of duty cycle, at another resistor value of 3.22 ohm, so the minimum inductor value is 9.6 microhenry. And another scenario of another duty cycle of 0.33 with 5.33 ohm of resistor. So L min we found out to be 17.86 microhenry. In another 0.33 duty cycle of R equal to 3.2 ohm. So L min calculated to be 10.72 microhenry. So which value actually need to be implemented in our circuit here? We cannot change all the time because we have to select any of this value to be put inside the circuit and deliver to the market. So in actual case, actually once we calculate the minimum value of inductance, we shall increase another 25% such that it will maintain or ensure that the circuit continuous delivery current at CCM. So increment of 25%. But for this calculation, what is the minimum to make sure that it operate in boundary at least? So we choose the highest possible values of the team of the available selection: 16, 9, 10 and 17. So the highest is 17.8. so this is the value to maintain, to determine the circuit is providing continuous current for every possible operating condition. So next is question 3. Consider a buck converter with following parameter. So given source is 80 volt, resistance of load 18 ohm, output power at this value 100 watt. It's given already the inductor value, switching frequency of 120-50 kHz. So determine the mode of operation. So we want to ensure that is it operating in CCM or boundary or DCM. So first of all, we need to find out what is the duty cycle of the system. So V out equal to Vs times D, or D is equal to V out divided by V source. But V out now is equal to P equal to V square over R. So V out is set of P times R. So 100 times 18 divided set. So we got V out of 42.43 volt. So 42.43 divided by 80 volt of source. So the cycle is 0.53. So with this amount of inductor value, we try to find out what are the IL min of the system when this inductor value being used. So this is one of way to make sure that what mode the system is operating. So we put in 1 over R, which is 118 volt, 42.43 volt output. The cycle given here with the amount of inductance value and the switching frequency. So the calculated minimum operating current at that resistor value is 2.19 ampere. So means that this is above 0 ampere. So it is for sure that the system is operating at CCM and continuous current mode. So for B, determine the range of resistor for the converter to remain in CCM. So we have here IL min equal to V out times I or 1 over R. The formula given here. So we set this IL min at 0. Set at 0 means that we calculate for R. So for R, with the given of the value of 0.4 milli times 150 kilohertz. So we shall get the R of 255.3 ohm. Means that for the range of 18 ohm up to 255.3, the converter will operate in CCM. Above it will be, or at that value is a boundary.